Hey everybody, in this video we are graphing a very basic transformed version of the absolute value function. So first thing, what is an absolute value function? I'm a big believer that not the best name for it because you could take the absolute value of lots of things. If you took the absolute value of a quadratic, it's not going to look the same as the absolute value of the cube root function or the absolute value of a sine wave, right? But in this case, what we usually default to when we first learn it is the absolute value of a linear equation. And what happens is you had originally a line, a linear equation, and when you take the absolute value of it, all the parts of the line that were below the x-axis are going to become positive, and that's what creates that V shape. And then perhaps you have a -2 or something on the side, and that might shift it down 2 or up 2, and so on. And then out front, sort of still like our slope. Linear and absolute values, you could apply slope the way you've always done with rise over run, and that's fine. Anything else, those graphs are curves. They're not made of pieces of line or lines in general. So the curve, okay, a curve has a slope that changes throughout. You will not be applying up and over, up and over, up and over the same values over and over again because that would not curve, okay? Anything that's a constant slope of line, it's flat. It's the same slope, rise over run, boom. You could do it that way. Anyhow, let's get into it. So the absolute value of x, the parent of this, if you will, looks like that. That is the parent function. That is the most plain version of this graph. Nothing fancy going on with that. Now, if I were to graph that, what's the absolute value of 0? It's 0. It's the absolute value of 1, 1. Input is x, and you put something in. Output, what you get out of it, all right? So if I put in a 1, I get a 1. I put in 2, I get 2, 3, 4, and so on. So right here, up in quadrant 1, it would look like that. Now, what's the absolute value of -1? 1. Of -2, it's 2. Of -3, -4, and so on. So as we took the absolute value of these negative x values, they gave us those positives. Now, that's the parent function. How about this transformed function? This one's quite basic, so I'm just going to get right into it. I go into more detail of how these transformations all work in the upcoming videos because those graphs are a little bit more intricate, so I just want to offer more support there. But because this one's not too fancy, I'm just going to get it down on the paper. This over here, all right, that is going to shift it either to the left or to the right. This over here is going to shift it either up or down, all right? So y equals a absolute value x minus h plus k. So by default, it's usually a minus h would move it to the right, plus 3 will move it to the left. So 1, 2, 3 units to the left. And then -2 is going to go from right there down 2. So -2 and -3, again, left 3, down 2. That's what those pieces of the equation that we're working with all did. Just focus that a little, sorry. So I'm over here for my vertex. So this guy moved over, down, and no stretches or compressions are made. So the slope is still 1. Whatever number you really see in front of that absolute value bar to the left is essentially telling you your slope. If it were negative, that absolute value would no longer have a minimum value or a minimum point, but it would have a maximum. It would flip over vertical flip, vertical reflection. And really that's it, guys. So your vertex is -3, -2. It is an absolute minimum. It is the absolute lowest point on the graph. Nothing is lower than it, no matter what. And it goes up in both directions forever. It gets wider in both directions forever. If you are to do end behavior, it would be up and up. But that's it. So I hope you feel smarter. I hope you feel good about it. Thumbs up if you do, thumbs down if you hate it, and click through for the next example. Or if you see something that piques your interest a bit, like, you want to practice it more or watch something more, go ahead, go there. And I hope you do well on your algebra final exam. All right, bye. See ya.